Basically, if I have one circular coil, then magnetic flux will be BA. If we have two circular coil, we will have magnetic flux is equal to BA plus BA 2BA. Then we come to know with the structure which has lot of circular coil just to increase the magnetic flux intensity. And this type of structure we call as the solenoid. So current passes through it. Whenever current passes through any coil, it behaves as a magnet. So this is what we call as a temporary magnet. So lot of magnetic field lines will pass across this structure, which we call as the solenoid. So in case of solenoid, flux density will become as BA times N. So magnetic flux in case of solenoid will be BAN, where N is nothing but number of turns of the coil. So whenever you will be seeing a problem based on solenoid to find flux, they will also be providing you that solenoid has 2000 turns or 100 turns or so on. So that you need to use in your problem to get the answer. So use flux density in case of solenoid, which will be BAN, where phi is magnetic flux, N is number of turns, B is magnetic field, and A is cross-sectional area. So unit will be meter square, magnetic field intensity is Tesla, flux will be Weber, and N is N. So unit of that is basically Tesla into meter square. This is B into A. B is Tesla, A is meter square, and this we called as a Weber. We also call this as a Maxwell in CGS system of unit. So, and the conversion between Maxwell to Weber will be 10 to the power minus 8. This you will never see, but SI system of unit you should know. Moving to problem solving, read what is the angle between area vector and B?
60.
Option C.
120.
So flux will become BA cos theta. B is B, A is A, and angle between B and A is 120 degrees. Okay. So cos of 120 degree. Cos 120 degree is minus 1. So BA times minus 1 by 2. So minus BA by 2. Phi will become ban. So B is 5.1 times 10 to the power minus 3 multiplied by area. Area will become circular coil, right? So pi times 0.4 square multiplied by number of turns. So solenoid has 3 turns. If you do all that, you will get flux as WB 0.773. Now force because of on a charge. This is a bit tricky. When I do cross magnetic field. Okay, let's say dark magnetic field is like this. This is B. What is the meaning of cross for magnetic field? That means field lines are going into the plane. Field lines are going inside your laptop. Have you seen screw? So that is how it looks like. And over here, we have sign like this. So when you try to rotate it, it goes inside. So what is the meaning of this cross? That when you try to rotate, it goes inside. So this cross means field lines are going into the plane. So whenever cross is written, you can understand that field lines are going into the plane. Do we have? No. Okay. And whenever dot is written, let's say these are the dots for magnetic field lines. That means field lines are coming out of the plane. Since it is in 3D, force is like Q V cross B. So we need to know that this direction also. Cross means going into the plane. Dot means coming out of the plane. Rest other directions are clear. This is X direction, that is Y direction. Cross is into the plane. If a charge, any positive or negative charge, with some velocity is placed inside a magnetic field, then this charge will experience some force. So what theory says, whenever a charge, whether positive or negative, is placed into the magnetic field, then it will experience a force. So charge should have some velocity by which it is moving. Then moving charge will experience a force. If you could recall your electric field lesson, we have learned static charge does not have magnetic field. A static charge has only electric field. Now the charge is moving with the velocity. That means it will get affected by the magnetic field also. So whenever this charge moving with the velocity v is placed in a magnetic field, then this charge will experience a force. Okay. And the value of this force will be equal to F is equal to Q, the charge magnitude, V, the velocity by which it is moving, times B, which is magnetic field intensity, multiplied by sine theta. Okay. Which is angle between the this velocity vector and magnetic field vector. So right now it is 90-degree because magnetic field is inside and charge is moving like this. So in this particular case, which we are seeing, has angle between velocity vector and magnetic field vector is basically 90-degree. In vector form, since this is a force, there is another way by which we can represent this force vector. That is basically q times, that is a scalar quantity, multiplied by v vector cross b vector. And v vector cross b vector is nothing but vb sine theta. Now you must be wondering that we can simply keep qvb sine theta. Why this cross and all? This cross help us to get the direction of force. Now we are very much clear about the magnitude that a moving charge placed in a magnetic field will experience a force and the value of that force will be equal to qvb sine theta. Now, what is the direction of force? In which direction that force will be applicable? So to know that, we'll keep our fingers in direction of velocity and curl it towards the direction of magnetic field. Whatever thumb is representing will be the direction of force. So right now my velocity towards rightwards, if I curl towards inside my laptop, so I am getting the direction of force that is upward. So the force in this case will be nothing but positive y-axis. Now, v vector is like this. This is velocity and that is the charge particle. Now, if I keep my fingers towards v vector and rotate towards my laptop, so the direction of force coming upward. Okay, so velocity in x-axis, b axis,
z-axis,
and force comes out to be positive y-axis. So what will happen to this charge particle? This will experience a force, so it will try upwards, so it will try to move in this direction. Then further you will apply, then it will further try to bend, and then again bend, then again bend. So always the direction of force will be changing. So this charge particle will move in a circular path. So whenever a charge particle placed perpendicular to the magnetic field, it will get force in a way so that it completes the circular motion. If you see this particular picture over here, so we have thrown the charge particle like this in a magnetic field where field lines are coming outwards, then force will be acting in a way so it start moving in a circle like this. Same thing happen over here also, that force is perpendicular, v is in this direction, so this charge particle will also move in that direction. Okay, you must be wondering why this charge particle is moving in this circle clockwise and why this charge particle is moving in an anti-clockwise, because in this velocity vector in rightwards, over here you can see velocity vector is leftwards, so the circle is also different. Okay, so the value of the force will be equal to q v cross b. That all formula also you can write, or for magnitude you can write q v b sine theta, and direction you can do using v cross b. Direction is important. This is the area where difference will be created in our marks. Okay, those who understand direction well will be able to answer at least two more questions. Okay, so v cross b. Keep your fingers towards b, curl it towards b. Wherever thumb is pointing will be the direction of v. Okay. So formula is very simple. It's like a charge particle moving with a velocity v inside the magnetic field. Then this charge particle will experience a force and value of that force will be equal to q v b sine theta. Okay. Now this is the magnitude of force and direction of force you can simply find using velocity vector and magnetic field vector. Let's say velocity vector in this direction and magnetic field vector in this direction. I'll keep my fingers towards V and rotate towards B. So thumb is pointing out of the plane. So in that particular case, the force is out of the plane. So force vector will be out of the plane. Okay. When V is in x-axis, B is in y-axis. Why in these two pictures and the previous one we were able to see force on y-axis or minus y-axis? Because magnetic field is taking z-axis. One more catch in this formula is whenever velocity and magnetic field are parallel, let's say magnetic field is also in this direction and you are throwing the charge particle also in the same direction, then the value of force will become zero because the angle between v vector and v vector will become zero and sine zero is zero. So it will not experience any force. So if magnetic field lines are like this and you are also keeping the charge particle q with a velocity v along that, then there will not be any force. So in this formula, if any two becomes parallel, then there won't be any force. So if v and b are parallel to each other, then of course it will not have any force because of magnetic field. V and b has to be perpendicular to experience maximum force. And if they are at certain angle, then we will take the perpendicular component and then we will try to find. Once we'll do the problems, it will become more clear. For now, your understanding for the magnitude of force and the direction of force needs to be clear.